Hi, Justin. Here's my take on the homework. 2.1 sites in a compound with a delta plus are the places most likely to be attacked by an anion such as hydroxide. In the compound below, identify two such carbon atoms. Little delta plus means it's electropositive. So what you look for is a carbon that's next to an electronegative element. Anything to the right of carbon is likely to be more electronegative on the periodic table. So oxygen is and chlorine is. Therefore, this carbon is subject to attack by hydroxide. It can do a nucleophilic substitution SN2 reaction to kick out chloride and replace it with hydroxide to make that alcohol there. This carbonyl carbon is also electropositive by virtue of that inductive effect that we just mentioned, meaning oxygen's electronegative. It's sucking the electrons away from carbon, so it's a little bit plus there, a little bit negative there. There's also what they call a resonance effect. I don't know if they've discussed that yet, where those two bonds that form that carbonyl group, one of them can take its electrons and put them directly on oxygen, giving it 3 lone pairs, rendering that fully electronegative and giving you a formal positive charge at the carbonyl carbon. Therefore, by both the inductive and the resonance effect, it's electropositive at carbon, and you can have OH attack this. This will give a 1,1 diol, OH, OH temporarily, and those usually move on to do something else. But anyhow, the answer is positions 2 and 5. Boy, that was a long answer. Let's see if I can get to the next one.
Ladies and gentlemen, the ice cream truck has arrived.
The ice cream
Please
truck has
join us
arrived.
outside
Big
for an
deal.
ice cream social.
Whoop-de-doo. Okay, 2.2, which compound would have a higher boiling point? You always analyze the intermolecular forces between two identical molecules. That's what boiling is when these things, which are, there'd be more than one of these, right? This is diisopropyl ether. And this would be, imagine a cup full of this stuff, tons of molecules. You would have London dispersion forces between the hydrogens and adjacent hydrogens, very weak. You could have a dipole force between an oxygen and either a carbon or a hydrogen, a little bit stronger, but this is stuff would be a relatively low boiling liquid. This thing is an isomer of it. If you count up the carbons and the oxygens, they're identical. Functional group is identical, but the difference is that the the intermolecular forces are more available here. So this substance would have the higher boiling point because although it has an equal number and identical intermolecular forces between the molecules, they are more available. This one's all squished together and it's hard to get at some of them. Therefore, this one would have the higher boiling point. Here you have very similar molecules, just hydrocarbons, cyclohexane and cyclopentane. However, this one would have fewer intermolecular forces per molecule, right? This is C6H12, this is C5H10. So you have more intermolecular forces that must be broken to turn this from a liquid into a gas. Therefore, cyclohexane would have the higher boiling point, more intermolecular forces per molecule of the same variety. LDF, London dispersion forces. Here you got a big difference. This is just an ether, diethyl ether. It boils in the palm of your hand. This is butanol, which has a boiling point higher than water. Alcohols are capable of hydrogen bond forces, which are among the most powerful, and they will dominate. So this would have a much higher boiling point because it is capable of hydrogen bond forces. This one is not. Is that it? Yep. Hey, I hope that helps, and keep in touch.